Welcome to July 19th LeetCode challenge. Pascal's triangle. Given an integer row, num rows, return the number of num rows of Pascal's triangle. In Pascal's triangle, each number is the sum of two numbers directly above it as shown. So Pascal's number is a basic combinatoric type of kind of triangle. It's used to calculate polynomials as well, but basically Pascal's triangle basically is the sum of the two numbers above it. So here you have 2 and 3, and then 1 plus 3 is 4, then you get the pattern, right? So basically the top two kind of sum together and they create the number below it. So this is an example of 5 here. If you have 1, 2, 3, 4, 5 rows, and Pascal's triangle will look like this. So return an array of an array. And the rows has 1, then you return an array of 1. So number of rows is between 1 to 30. So this is an easy question. The answer itself is not really, understanding is pretty easy, but let's just go about solving this. So we would actually use a straightforward or dynamic approach to this. So let's do dynamic programming for this. So basically you have 1, and this is going to initialize the first row. So for each row R in the range of, say, num rows minus 1, we want, because we already have the first index, so basically we want n, a number of rows minus the first one, right? What we're going to do is define, let's see, we could call it temp maybe, and that's going to be the first element that we're going to add 1. And then for each column C in the range of 1 to row plus 1, so it's using basically a for loop within a for loop now, which is going to be n squared. We're going to temporarily append the following. We're going to append the rows before it, so dynamic program array at row column minus 1 plus dynamic programming array at row and column. So basically we're adding the top two rows above it, and we're appending it to temp. Exit this loop. Temp will be updated to append 1, because we add 1 to each side of this, right? We add 1 to all. If we look at the right diagonal, it's 1, so we add that. Then we dynamic programming array append our solution, which is our temp, and then return our dynamic programming array or output, right? And this should run at big O of n times n time complexity, which is not very good, but it works. Space complexity is big O of n as well, because we're doing for each height, each row of Pascal's triangle. Alright, that's it. Have a great day, guys.